This is a right triangle. The Pythagorean theorem only works if you have a right triangle. We know it's a right triangle because this box is a right angle. So a right triangle is a shape with three sides, and one of those, or two of those sides make up a right angle. Directly across from your right angle is, we call it C, but it's known as the hypotenuse. Which now my button might make sense. My button says the hypotenuse, because it's funny. So he's across from the right angle. And your hypotenuse, or the side across from the right angle, is always the longest side of a right triangle, which is what this defensive player had to run. So he was running along the hypotenuse, so he's running the longest side of the triangle. A and B, the sides that make up the right angle, are called legs.
What does it say?
This is the longest side of a right triangle across the right angle. I should say across from. So the important thing on here, all of it's somewhat important. The important thing is you can recognize when a triangle is a right triangle just with this little box. And you know that directly across from that is called the hypotenuse. Because some questions will just say, on this right triangle, which one is the hypotenuse? So you always just pick the one across from the right angle. And then this is what we wrote at the end of our tests after we did that investigation with the squares. So in a right triangle, the sum the square. Sorry, this is backwards. The square of the length of the hypotenuse is equal to the sum of the squares on the legs. This is very wordy and probably pretty confusing. But it just means, in a right triangle, so a shape that looks like this, the square of the length of the hypotenuse, so c squared, is equal to the sum, so we're going to add the squares on the legs. So we're going to square this leg and add them up. So this is your formula. You don't have to memorize it. On your SOL test, there will be a formula sheet that has this formula on it. You need to know when to use this formula. So this is the only formula with a triangle we have learned in class this year. You probably know your area formula. When we do our area and perimeter unit, a lot of people will get confused on if they should use the Pythagorean theorem or the area of a triangle because they're both triangles. But right now, we're talking about the outside of the right triangle, so the legs and the hypotenuse, and we're looking for lengths. So we're going to use this formula, a squared plus b squared equals c squared. These are examples. These are called Pythagorean triples. So like 5, 12, 13, they're all whole numbers. 7, 24, 25, and 3, 4, 5, they're all whole numbers. Multiples of these numbers are also Pythagorean triples, so like 30, 40, 50, 9, 8, 10. Oh no, 9, 12, 15. These are only useful to memorize if you didn't want to do a lot of work. So like this one, 5, 12, 13, that's a Pythagorean triple, so I know it's a right triangle, but we can show you why. So first, we're going to verify that it's a right triangle, so I think that this is my right angle. I know that 5 and 12 are the legs, and 13 is the longest side, so that's the hypotenuse. If you were just given a list of numbers, you just pick the biggest number to be the hypotenuse. So if instead of giving you a shape, they told you like 5, 8, and 10, 10 would be your biggest number, so 10 would be your hypotenuse. It's good practice to rewrite the formula. And then we can plug them in 5 squared plus 12 squared. We're checking to see if that's 13 squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. And 13 squared is also 169. So, when you plug these numbers into your Pythagorean theorem, you get a true statement, which means this is a right triangle. So this is just verifying. You just plug it into your formula and check it. So you guys can try this one. It's a little different because there are decimals, but you still solve it the same way. Plugging your numbers, you would do 3.6 squared, 7.7 squared, add them up, see if it's the same thing as 7.9 squared. So you guys do that one quickly. Alright, is this a right triangle? No, because when you do the Pythagorean theorem, you don't get the same number on both sides. 7.7 squared plus 3.6 squared is 72.25. 7.9 squared is 62.41. So these are different numbers. This is not a right triangle. Other questions? Alright, you won't get a lot of questions like this, maybe like one, and then one will be multiple choice, and it'll say which of these four is a right triangle or which of these four is not a right triangle. But you don't do a lot of justifying, you do more solving. So this is a right triangle, it has a little box in there, and it says find the missing side. Do you label this side A, B, or C? C. C is our missing side, it's the hypotenuse, it's the longest side. So we'll write down the formula. A squared plus B squared equals C squared. We'll plug in the values. It does not matter which of these you label A and B. You can interchange the legs, so I'll just do greatest to least. 4.3 is A and 11.3 is B. So we'll plug them in. 4.3 squared plus 11.3 squared equals C squared. You solve this like an equation. We have to simplify this first, so we'll square all the numbers. Our first step will always be to square all the numbers. So 4.3 squared is 18.49. 11.3 squared is 127.69. So I've squared everything that I can. We can't square C squared yet, so now I need to add these numbers together. And you get 146.18. And does anyone know how you get C by itself? Go ahead. Take the square root. The square root of C squared is just C. Whatever you do to one side, you have to do to the other side. So if you square root one side, square root the other side. So this is already in my calculator. I'll just take the square root. which is this button next to the divide sign, and you get C equals 12.09049213. When you write your answer, this says round to the nearest tenth. If it doesn't specify, then round to the nearest hundredth place. Always go with 2 decimals unless it says otherwise. So later in class we'll do a color by number. All of that is rounded to the nearest hundredth place. So if it doesn't say, do 2 decimal spots just to be sure. Okay, so this is when you're missing the hypotenuse. You could also have a missing leg. So which should I label this side? Any guesses? What did you say? So across from the hypotenuse is always C. So which should I label this side? B or A? It doesn't matter. Write our formula. A squared plus B squared equals C squared. Plug in our numbers. One of my legs is 7, so 7 squared. The other leg is B. That's the one we're missing, so we'll write B squared. And across from my right angle, the longest side is C squared. And so this time, I'm missing one of the legs. So on the front, you're missing the hypotenuse, the longest side, so you're missing C. On the back, you're missing a leg, one of the shorter 2 sides, so you'll label it A or B. Solve this, so we'll square everything first, just like we did before. 7 squared is 49. And 14 squared is 196. On the front, we added these 2 numbers together, but we can't do that. We need B squared by itself. How do I get rid of 49? Go ahead, Hannah. Good. So just like solving an equation, which we did a long time ago, to get B squared by itself, we need to subtract 49. So anytime you're missing a leg, you will always be subtracting, Jake. So B squared equals 196 minus 49. And then B squared is not my answer. B squared would be the area of a square if I drew it right here. What would B be equal to? How do I solve that? Good. Just like we did before, to get rid of squaring a number, we take the square root. So here's 147. Take the square root, and you get 12.12. Oh, round to nearest tenth, 12.1 again. Remember, if it doesn't say, go with 2 decimal points, so you could write 12.12. All right, you guys do this one. I'll leave this up here as your example. Remember, it doesn't matter if you label the legs A or B or B or A. As long as you use one of those, you have to label your hypotenuse C. The other ones are interchangeable. figured that one out, you can move on to the next two. At least set them up and get to the very last step. And if you don't remember simplest radical form, I will explain it to you. Stuck. I put the first part up there. All right, what'd you guys get? 11.4. If you did not get that, look up at the front. Oh, make sure we round correctly. So 11.36 rounds. The 6 bumps the 3 up to a 4. All right, simplest radical form. Same thing, A, B, and C. This time we're missing a leg. When you do this practice problem, you're missing the hypotenuse. So, a squared plus b squared equals c squared. You don't have to write this every time. I'm going to do it for the notes just so you can keep hearing the formula over and over again. But if you just wanted to go straight to the second step, that's okay. A squared plus b, which is 11 squared, equals c, which is 13 squared. So we'll go through and square everything that we can. A squared plus 11 squared is 121, equals 13 squared, which is 169. We want a squared to be by itself, so we'll subtract 121 from both sides. A squared equals 169 minus 121 is 48. In all the other examples, we take the square root of both sides, and we get whatever the square root of 48 is, which is 6.9. But this says write your answer in simplest radical form, which means that we'll leave the square root of 48 as it is, and we'll pull out any possible perfect squares. So we did this in our first unit. It was a very long time ago, so I understand if you forgot. But you'll look at 48 and think, what two numbers make up 48? What do you multiply?
6 and 8.
Okay, 6 times 8 is 48. Neither of these numbers is a prime number. What two numbers make up 6? Okay, so 3 times 2 is 6. 3 and 2 are both prime. What makes up 8? 2 times 4, 2 is prime. What makes up 4? Okay. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And 24 times 2 is 48. So this list of numbers is all of the prime numbers that makes up 48. So I'm going to rewrite this. 3 times 2 times 2 times 2 times 2. And then we're simplifying the radical, so we're pulling out any perfect squares. So 2 times 2 is 4. 4 is a perfect square, which means we can pull it out. And what's the square root of 4? 2. Again, 2 times 2 is 4. To pull it out, we take the square root. And 3 does not have anyone to buddy up with, so that one gets left inside the square root. So I can pull out a 2 and another 2 because they each had a buddy, and 3 did not have a buddy, so I left it inside. And then we multiply these. 2 times 2 is 4 times the square root of 3. Okay, you guys try this next one. If you guys finish that one, you can work on the do-word problems. So most people have gotten to this part so far. So take the square root. 25 times 10 is 250. Start there. Alright, if we're to finish this up, 25 times 10 is 250, 5 times 5 is 25, 5 times 2 is 10. So we get to 250, we do 5 times 5, which is 25, times 5, which is 125, times 2, which is 250. So you grab a group of 5s, that pair gets taken outside, you just write it down one time. This third 5 and this 2 don't have anybody to buddy them up with to pull them outside, so 5 times 2 is 10, and that gets left inside. You can only leave the house if you have someone to go with. So these two 5s can leave because they become a pair. You pull them outside. Alright, 5 and 6 I'm just going to set up for you. Number 5 says, what is the slant height of a cone with a height of 11 and a radius of 5? So in a cone, you have the slant height. The height is always perpendicular to the base, so that makes a right angle. So this long side is 11. That would be A. The short side is 5. That would be B. And the longest side, this hypotenuse, is across from the right angle, so that would be C. A squared would be 11, B squared would be 5, and C squared is C squared. And 12.1 is not always your answer. It's just, for some reason on these notes, it's always 12.1. There is a question out there that you will probably see, and instead of giving you the base, it tells you that the whole length is 10, so you would have to find out that half of it is 5. So if they're labeling the entire length, make sure you know that the part of your triangle is 5. And if you get it wrong, I think it's on stations or something that we do, I'll point it out to you. Example 6, whenever you see word problems, it's always great to draw a picture. You're locked out of your house and the only open window is on the second floor, 25 feet above ground. So here's 25 feet above ground. You need to borrow a ladder from one of your neighbors. There's a bush along the edge of your house. So you'll have to place the ladder 10 feet from the house. What is the length of the ladder? So this would be the ladder that you need to reach the window. Now the world is not perfect, but we are going to assume that the wall of the house and your lawn are completely flat and perpendicular. You'll have to assume in a lot of these problems. So this is how you set it up. The ladder would be your hypotenuse. It's across from where the right angle should be. 10 squared plus 25 squared equals c squared. And whenever you're doing these problems, if you wanted to double check yourself, this is the longest side, so 12.1 should be longer than 11 or 5. Same with the second example, C is the longest side, so 26.93 should be bigger than 25 and 10. So let's make sure you do it right. If you're solving for a leg, it should be smaller than the hypotenuse. Otherwise, you did it wrong. Okay, questions?